Okay, thank you, Han.
Okay,
You need to stand by, so you need to stop the recording. Okay?
all right,
After an hour.
I'll call you.
okay,
Bye.
bye.
Well, guys, are we okay now then?
Yeah, we're okay. I just want to add one thing. So the easiest way to record from anywhere is probably adding your other email as a host or as a co-host.
Uh-huh.
So when you go home, then you can next time you'll not face this problem.
Okay, thank you. So we're recording now. We should be okay. We have 11 people here. I am at school today. Sorry for the confusion. Did anybody access the last two videos? I put them on syllabus. The page. Did anybody go there and try to log in?
Yeah.
Did it work okay?
Yep.
All right. And then there are on YouTube too. They're the link from that page to my YouTube page. You can go take you straight there. Okay. So last time, okay, so I'm just, I need to look at, okay, so last time we did the product rule that says del of xn yn is del xn eyn plus xn del yn. Okay. Now, today we're gonna do, let's replace n with k. Okay. K, you will see why. Okay. So let us, so what we're gonna do today is we're gonna do the so today we're gonna do summation by parts. Summation by parts. So I am going to, I'm gonna solve. So I'm gonna write xk del yk equal to del xk yk minus del xk eyk. Now then I'm gonna sum from n0 from k equal n0 to k equal n minus 1. So if I do that, I'm gonna get k equal n0 to n minus 1 xk del yk equal to k equal n0 to n minus 1 del xk yk minus k equal n0 to n minus 1 del xk eyk. Okay. Can you see the board fine?
Yes.
All right, thank you. So now this is the same as k equal n0 to n minus 1 xk del yk equal to, you see, this is the whole difference. And this is from k equal n0 to n. Remember, n minus 1 becomes n minus k k equal n0 to n minus 1 del xk eyk. So this is a summation by parts formula, right? Is the picture too dark or is it okay?
Yeah, it's okay, but in some places, like there is a little bit of glary, so it's fine. We can see like the board clearly. That's fine.
But there's a glare. Is that what you're saying?
Yeah, in some like there are some light, so you're seeing the like the bright reflect of the light.
Yeah. Does that help the glare or not? No?
Yeah, it reduces the glare. Yeah, 1 point.
Okay. All right. So this is a summation by parts. And so if you look at for the calculus, remember it says A to B U dV equal UV, okay, between A and B minus AB UV minus VDU. Remember that? So look at it here. Okay. Another way of writing this is I replace k equal n0 to n minus 1 yk del xk equal to xk yk from k equal n0 to n minus k equal n0 to n minus 1 del yk exk, another formula to that. Okay, so you got two formulas. All right, any questions? Let's do an example. Now I'm gonna turn my computer around because I have two boards. All right, so let's take a look at, this is example 1.14. For A different than 1, we wanna evaluate, we're gonna evaluate k equal 1 to n, k a to power k. Okay, so let us use this formula here. So let's use, I'm gonna rewrite the formula for you. K equal n0 to n minus 1 xk del yk equal to xk yk from k equal n0 to n minus k equal n0 to n minus 1 del xk eyk. All right, so we're gonna take, so you need to choose, you need to make the right choice. Okay, we need to make the right choices here. So it seems like I'm gonna take xk equal k and del yk equal ak. Now in the formula, I need del xk. So del xk equal k plus 1 minus k equal 1. And yk equal to del yk, that is AK, and that is AK over A minus 1. You remember the table? Okay? Because I need, if I chose, since I chose xk equal k and del yk equal a to power k, then I need del yk, del xk, sorry, computed it here, and then I needed yk. So this, so k equal 1 to n, kak, according to this formula, is xkyk, is k yk times ak over a minus 1 from k equal to 1 to n plus 1. Remember, you see the formula has n minus 1, you get n. If this is n, you will be n plus 1. Okay? And so minus k equal 1, minus k equal 1 to n, del xk is 1 times eyk. This is yk. Eyk is ak plus 1 over a minus 1. Let me finish it off, and then we will evaluate what this is equal to. Does anybody have any question about it? So let's continue. That is k over a minus 1 ak from k equal 1 to n plus 1 minus a over a minus 1 k is 1 to n ak. Okay? And this is, again, equal k over a minus 1 ak, k is 1 to n plus 1 minus a over a minus 1 square ak, k equal 1 to n plus 1. Okay? So now all we need to do is evaluate at n plus 1. So this is equal to 1 over a minus 1. Here I'll have n plus 1, a to power n plus 1 minus a, because you put k equal 1, you get 1 times a. So k equal 1, not n, remember. Minus a,
We can't see the section of board you're writing on.
okay. How's that?
Perfect,
Is
thank
that
you.
okay? Uh-huh, thank you. Minus a over a minus 1, this would be a to power n plus 1 minus a. There you go. Okay? Of course, in the book, I do simplify the answer, but that's okay. Okay? Any questions? Okay, I am done with this chapter. I'm gonna move on to chapter 2. So I'm gonna switch my screen. All right. Okay. So I'm gonna erase the board. All right. So now we're gonna take a look at chapter 2, and I called it linear difference equations. Okay. So in calculus, we looked at x prime of t equal ax of t with x of t naught equal x naught. Remember this equation? And which has the solution x of t equal x naught e to the a t minus t naught. Okay? And this is for t bigger or equal to t naught. Okay? So you've seen this in differential equation, may I say. Now, so the analogous is del xn equal bxn with xn of 0 equal n0, n bigger or equal to n0. Okay? Now, if I write this as xn plus 1 minus xn, I'll get bxn, or xn plus 1 equal to 1 plus b xn for n bigger or equal to n0. Okay? So if we let a equal 1 plus b, then we have xn plus 1 equal to a xn, n bigger or equal to n0. So this is the one we're gonna be looking at. Okay? You see, this one, the analogous of it is this one. Then we wrote it like this is a better way for us because we're gonna do some kind of iteration. So what is x1? So for n equals 0, if n equals 0, then I have x1 equal to a x, no, sorry, n equal n0. All right, so let me see. Oh, n equals 0. Oh, sorry. I made a mistake. I'm taking x of 0 here. Okay. I'm taking n0 to be 0. All right. Okay. So for n equals 0, I have x1 equal ax0 equal ax0. Can you see well?
Yes.
All right. For n equal 1, x of 2 equal ax of 1, and that is a times ax0, and that is a square x0. Correct? Okay. And so for n equal to 2, I got x to 3 equal ax2. That is a times a square x0. That is a cube x0. So if I keep going that way, I'll get xk equal to ak x0. So by an induction argument, we get xn equal a to power n x0 for n bigger or equal to 0. So that is the solution. That is the solution of xn plus 1 equal to axn. Okay? You can easily verify this. We can easily verify this. To verify, if you like, what is xn plus 1? Xn plus 1 from here is an plus 1 x0. That is a times an x0. That is axn. Verify. And for n equals 0, we have xn equal an x0 or x of 0 equal a to power 0 x0. That is x0. So the initial condition and the solution does indeed satisfy the difference equation. So that is a solution. Okay? Now let us take a look at the behavior of the solution. All right. Any questions? All right. So recall, if I have x prime of t equal axt with x of 0 equal x0, then the solution is x of t equal x0 e to the at. Correct? So if I look at the limb as t goes to infinity of x of t, remember this as t goes to infinity means LIM as t goes to infinity, all right? Were you able to see this? Okay. Now, if I take a limit here, that is the lim as t approaches infinity, x naught e to the at, and that is x naught lim as t approaches infinity e to the at, and that is equal to 0 if a is less than 0, equal to infinity if a is bigger than 0, right? And equal to x naught if a equals 0. You see what happened? So this is important because in some cases, I mean, we need to know the behavior of the solution as n or t goes to infinity. So what happened to the system that the solution represent as the time grow? Okay. So in this instance, it goes to 0 if a is less than 0. So this is not the case. Not the case in difference equation. So this is not the case for us. And we're going to take a look at it a little bit. So for this one, so basically, okay, if this is x naught at t naught, this is x naught, and then the solution goes to 0 if a is less than 0, and goes to infinity if a is bigger than 0. You see that? Okay. So this will be xt and this will be t. Okay. That's it. And equal x0 if a is with 0. Well, is this the case for our thing? And the answer is no. So let's take a look. Okay, for our case, xn plus 1 equal axn, and x of 0 equal to x0, n bigger or equal to 0. And we notice the solution is given by xn equal to x naught a to power n. For n bigger or equal to 0. Can you tell me the asymptotic behavior of the solution depend on a, but does it depend on the sign of a or the size of a? Okay, what do you think? If you have a number between 0 and 1, let's say 1/3 to power n, that goes to 0 as n goes to infinity, correct? And if I have a 3 to power n, that goes to infinity as n goes to infinity, correct? So basically, the solution does not depend on the sign of a, but rather it depends on the size of a. So let's take some cases. Okay. So if a is bigger than 1, then xn either goes to plus or minus infinity, depending on the sine of x naught. So basically, this is n, this is xn, and let's say if x naught is here, then the solution will go to infinity. If x naught is here negative, then the solution will go like this. Is that clear? They will go to minus infinity. All right. 2 A is between 0 and 1. Well, as a between 0 and 1, xn, okay, xn decreases to 0 if x naught is positive, and then increases to 0 if x naught is less than 0. So what do I mean by that is the following. If I draw a picture, if x naught is here, then like this is A, this is A in between 0 and 1, and this one is x naught positive. If x naught is less than 0, then the solution will go like this. And this is your n. Okay? Any questions? Any questions? And then you can do so many things with them. Look at the book. See the book for more cases. Okay? See the book for more cases. Now, what happened if I'm gonna turn around. I'm using the other board now. Don't be confused if you're watching the video later. All right. So if A equal -1, what do you think happened? So if A equal -1, then the solution is xn equal -1 to the n times x naught. Yeah? Okay. So the solution is gonna basically so the solution will oscillate between minus x naught and x naught. Let's see what happened. So this will be x naught, that will be minus x naught. For n equals 0, you are at x naught. You are either here or here, correct? For n equal 1, let's assume x0 is positive. For n equal 1, you are at minus x0. For n equal 1, so you are here, correct? For n equal to 2, you are here. For n equal to 3, you are here. For n equal to 4, you are here. You see that? So this is n equal 1, n equal 2, n equal 3, n equal 4. You see how it does? It goes this, that, and so forth. It will alternate, oscillate between minus x naught and x naught. It will only take those values, okay? And so forth. There are interesting cases in the book I need you to look at. All right. Is there any questions? So let's take a look at an example. This is in the book. Let me. So let x naught be the initial population of a certain owl population. Certain owl species, may I say. Okay? And let's say they are growing at 2% a year. Okay? So basically, xn plus 1 is xn plus 0.02 xn. Okay? And that is 1 plus 0.02 xn, and that is 1.02 xn. And x of 0 equal to x naught. So the solution is x naught equal x naught times 1.02% to power n. So if the population is growing, what happens as n goes to infinity? And that will go to infinity as n goes to infinity, correct? Okay. All right. Now, all right. Okay. So before we looked at xn plus 1 equal axn with x0 equal x0, then the solution is xn equal x naught a to power n. Now, we want to look at xn plus 1 equal axn plus some constant b with x naught x0 equal x naught. So this is what we are trying to look for now. So again, let's do it by iteration. So for example, for n equals 0, we got x1 equal ax0 plus b. That is ax naught plus b. Okay? Why don't you go ahead and compute x2 and x3? I'll be right back. Go ahead. Compute x2, x3, x4. All right, I just had to go and get a drink of water. I'm back. For n equal 1, x2 equal to a x1 plus b. That is a x1 is ax naught plus b, a plus b, and that is a square x naught plus ab plus b. Okay, anybody has any questions? Now for n equal to 2, x3 equal to a x2 plus b equal a of a square x naught plus ab plus b plus b, and that is a cube x naught plus a square b plus ab plus b. Okay? So continue like this for n equal k, we get xk is ak x naught plus ak minus 1 b plus a square b plus ab plus b. We're always gonna have a b. So in general, we're gonna have xn equal to an x naught plus an minus 1 b plus a square b plus ab plus b. Okay? And if I factor b out, this will be an minus 1 plus an minus 2 plus a squared plus a plus 1 if I factor b out. Okay? Now, let's try to make some sense out of it. So, case 1. Okay? If case 1 is a equal 1, if I look at a equal 1, then xn equal to x naught plus b, and what is, okay? Sorry guys. And then I have 1 plus 1 plus 1. Those are n. So I'm gonna have x naught plus n times b. So that is the solution. Because if n equal 1, this will be n minus 1 up to here will be n minus 1 plus 1 will be n. Okay? So this here is n minus 1 if a equal 1. Okay? Will be n minus 1, this one. If a equal 1, then you add 1, you'll get n. So the solution, if a equal 1, you get x0 plus b times n. So basically what we are saying is let's take a look at this. Another way of looking at it is, let's take a look from here. We'll have xn plus 1 equal to xn plus b, or del xn equal b. Sum from s equals 0 to n minus 1. So we're gonna get, okay, we're gonna get s equals 0 to n minus 1 del xs equal to s equals 0 to n minus 1b. Well, what is that? That is xs from s equals 0 to n equal s equals 0. So basically s equals 0, you get b. So this is b plus b plus b. This is gonna be n times b. Okay? And let me finish. I would like to keep this. So another way of looking at it, so we have xn minus x of 0 equal b times n. This give me xn minus x0, and this is n times b. And that is xn equal to x0 plus bn, and that is x naught plus bn. Do you see that? Isn't that nice? Okay. Can you see all of this? All right. So you will see we got it back the same way. Now let's take a look about the case where n is where a is not 1. So now we're gonna take a look about a different than 1. Okay. So I'm gonna get rid of this. So now the case of a is different from 1. Okay. Well, so what do we know? We know that xn is an x naught plus b times 1 plus a squared plus an minus 2 plus an minus 1. Do we agree with that? That's from here. I just switched this around. And now a is not 1. So notice this is an x naught plus b times the summation of s equals 0 to n minus 1 a to power s. I could have used k if I wanted to. Okay? And that is, let me put the x0 ahead of an, plus b times, what is the antidifference of as? It is a to power s over a minus 1 from s equals 0 to n. Okay? And evaluate this. This is x0 an plus b over a minus 1 will be an minus, oh, yeah, an minus 1. Because if you put s equals 0, a to power 0 is 1. And so this is x0 an plus, let me see how I wrote it in my note. Plus b an minus 1 over an minus 1 plus b an minus 1 over a minus 1. And this is for the case a different from 1. Okay? All right. Any questions? You see how interesting this stuff is? It's totally different from what you are used in differential equation, isn't it? This is way more interesting, actually. There's more work involved. Can anybody tell me what the solution of this will be in differential equation? Think about it. I'm gonna flip the board here and say if you have differential equation x prime of t equal ax of t plus b, t bigger or equal to 0, x0 equal x naught, you see the solution is you multiply by the integrating factor. So if you multiply by e to the at on both sides, okay? So this is the integrating factors. Then you're going to have d over dt of e to the at x of t equal b e to the at. You see that? If I integrate from t0 to t, then I'll get t0 to t e to the as x of s. No, sorry. Then I'll have from s equals 0 to t equal to t0 to t b e to the as ds. And this would be e to the at x of t minus x naught equal b t naught to t e to the as ds. And then this is x of t, okay? And what is the integral? I mean, we can easily integrate this. We can easily integrate this one e to the as. So this is b over a e to the as from t0 to t, which is b over a e to the at minus, oh, okay, t0 is 0 here. T0 is 0, sorry. T0 is 0. 0 will be minus 1. So what we have is, so we have this one. So x of t equal x naught e to the minus at plus b over a e to the minus at times e to the at minus 1. Look at that. And then I'm going to have x of t equal to x naught e to the minus at plus b over a, and e to the minus at times e to the at will be 1 minus e to the minus at. So what I need you to look at the huge difference. Look at this one and look at the other equation. Xn equal x naught a to power n plus b over a minus 1 times an minus 1. An minus 1 over, okay, so let's take a look at it this way. Do you see the difference? Look at that. That's amazing. Okay? So what does that mean? So basically, a to power n became e to the minus a raised to power t. In the continuous case, this is what it is. In the continuous case, e to the minus at, which is this one, and then actually this is an. Okay? So I hope you can see the difference between the two. Huge difference. Any questions? I mean, the book has been doing very well, been adopted in different universities. And I know a couple of my friends are using it in India. And they like it because I do the analogy between differential equation and difference equation. So the student can tell what is the difference and how the difference is made. Okay? So this is about the whole idea to understand the concept, to go from the continuous case to the discrete case. All right, any questions? Oh, I'm getting tired here, but I'll keep going. All right, it seems like I am doing an example. Let's take a look at an example. So basically, solve 1 del xn equal to 2, x0 equal to 3, and 2 xn plus 1 equal to 1/2 xn plus 4. Okay? How would you do the first one? Solution 1. So if I do s equals 0, because x0 equals 3, that means my first point is 0, to n minus 1 del xs equal to s equals 0 to n minus 1, 2. And that is 2n. So this one is xs from s equals 0 to n equal 2n. So I'll have xn minus x0 equal 2n, or xn equal x0 plus 2n, and that is a 3 plus 2n. So that is the solution of Okay, I am writing here, right? Yeah. Okay. Any question about this one? Why don't you go ahead and solve two, see what you get. Well, for two, we have A is 1/2 and B is 4. So what is xn? Let's apply the formula. Is x0, xn is x0, a to power n. I'm going to rewrite the formula for you again. Plus b over a minus 1, a to power n minus 1. Okay? So that is x0. Oh, I didn't give you x0. Let's see. Oh, x0 is a 3, 2. 3. So will be 3 times 1/2 to power n, a plus b is 4 over 1/2 minus 1, 1/2 to the n minus 1. Okay? And so this is 3 to power 1/2 to power n, a plus or minus 1/2 minus 1 is minus 1/2, so minus 8 times 1/2 to power n minus 1. Okay? So what happened for this case as the limit as n goes to infinity of xn? That will be 3 times 0 minus 8 times 0 minus 1. Because as n goes to infinity, this goes to 0, this goes to 0. So that is 8. So as n goes to infinity, the solution goes to 8. Okay? All right. Any questions? Okay. Now I am gonna skip the application. If you are interested in the application, please, I encourage you to read it. It's a very interesting section. Okay, I'm gonna ask you to read, please read example 2.8. And this is referred to of the Tower of Hanoi. And so I need you to read this example. It's very interesting. And read it at home when you have time. And then I'm going to skip 2 sections and then go straight to section 2.2. Okay? All right. I am going to assign a homework today online. Call it homework 2, and you will get, if do you get notified when I assign the first homework by email or not? Can anybody answer? No. All right, but you know you have a homework that's due tomorrow, right? Midnight. Okay. All right, so I'm gonna assign another homework and you go check in and see when it's due. I'll take a look at it, depend on how many problems I am going to assign. All right, now we're gonna take a look at section 2.2. Again, in differential equation, we had x prime of t equal at x of t, okay? And xt naught equal x naught t bigger or equal to t naught. Now you see before we took x prime equal axt. So now a depend on time. It's not a constant. Remember, this one has a solution equal x naught e to the a t minus t naught. Well, what about this one? Okay. So this is what we're gonna do. I'm gonna remind you of the differential equation. So basically you are learning some differential equation or reminding you of it. All right, how would you solve this one? Okay, so let's take a look at it. Remember, the difference between the two is this depends on t. This is not constant anymore. Not constant anymore. I need you to be able to make the difference. This is a constant. Okay? So how do we deal with this? All right. Again, let me refresh you on differential equation. This is dx over dt equal at x of t. So this is dx over x of t equal to at dt. Integrate. If you integrate from t0 to t, dx over xs ds equal to t0 to t as ds. But this one is log. This is ln of x of s from s equal t0 to t okay? And that is equal to t0 to t as ds. Okay, so I have ln of x of t minus ln of x of t naught equal t naught to t as ds. So again, this is ln of x of t over x of t naught equal to t naught to t as ds. Take exponential or exponential on both sides, then you will get x of t over x naught equal e to the exponential if you do exponential on both sides, take e. So you'll have xt over x naught equal to e to the t naught to t as ds. Finally, or x of t equal x naught e to the t naught to t as ds. You see that? That's how that's what the solution looks like. Okay? In the continuous case. Any questions? All right. So it turned out to be, if for the difference equation, if I have xn plus 1 equal an xn with x of n naught equal x naught. Okay? So and we are assuming that an is not 0. We are going to assume an is not 0 for all n. For all n belong to n0, which is n0, n0 plus 1, and so forth. Okay? All right. So how would we calculate the solution? Let's try again for n equal to n0. All right. So we get xn0 plus 1 equal to an0 xn0. And that is, I'm just gonna see how I wrote it. an0 x naught. You see that? For n equal n0 plus 1, x of n0 plus 2 equal to, okay, I am here, an0 plus 1, xn0 plus 1, and that is an0 plus 1, xn0 plus 1 is this one, times an0 x0. All right. Let's do one more. For n equal n0 plus 2, can you see that? I cannot see it on the screen. My screen is blocked with something. Okay. So for n0, n equal n0 plus 2, x of n0 plus 3 equal an0 plus 2, xn0 plus 2. that is a and 0 plus 2. X and 0 plus 2 is a and 0 plus 1. A and 0, x 0. So if I keep going to x and 0 plus k, I'm gonna get a and 0 plus k minus 1, a and 0 plus k minus 2 times a and 0 x 0. Okay? So if I replace n 0 plus k with n, I get xn equal to a n minus 1, a n minus 2, a n minus 3, a n, if I am replacing with n, so that would be x naught and naught x naught. Okay? So this is the product of I equal n0 to n minus 1 ai times x naught, or x naught times the product I equal n0 to n minus 1 ai. So what I need you is to remember, in the differential equation case, it was xt equal x0 e to the t0 to t as ds. Do you see the difference? So this exponential is the product. You see it? So the exponential is the product. Okay? Now you are all familiar with this symbol, product symbol, aren't you? Anyone that is not familiar with this symbol? So so basically this symbol s equal to n0 to n minus 1 as, this is a notation, is equal to an0 times an0 plus 1 times an0 plus 2 times a n minus 2 times a n minus 1. Okay? This is the product. Now, so we assumption,
Professor, can you move the screen back over, please?
oh, I'm so sorry. Is that okay?
Yes, thank you.
Mhm. So this is the product symbol. So this is notation. This is notation. An assumption is that the product from S equal A to B of any number RS, or let me put K S equal to 1 if A is bigger than B. It's like exponential of 0 is 1. Okay? So this is we're going to agree on. Any questions? So let's do one example, then I will stop. How would we verify that this is a solution? Let's verify that this is a solution. So we have xn plus 1 equal an xn x of n naught equal x naught, and we said the solution is xn equal x naught s equal to n naught to n minus 1 as. I could use I used I here, forgive me. It doesn't really matter, all right? So how would we verify? What is xn plus 1? That is x naught s equal n naught to n as. So that is x naught times, evaluate this at n, times an times s equal n naught to n minus 1 as. I evaluated at n and wrote the product. So this is an x naught, the product of n naught to n minus 1 as. So that is an. What is this by definition? What is that? Isn't that xn? Sorry, the solution is xn minus 1, not xn. Oh, this is xn plus 1, sorry. Okay, what is that? Isn't that xn? Look at it. Okay, that is xn. What about xn0? xn0 equal x0, s equal n0 to n0 minus 1 as. What did we say? If the lower limit is smaller than the upper limit, what is the product equal to? You see that? You see why we have to agree on that? Okay. xn naught, we need to verify xn naught. Is x naught s equal n naught to n naught minus 1. So the upper limit is smaller than the lower limit. So the product by definition you and I agreed on is 1. So it will be x0 times 1 will be x0. So it is indeed a solution. Any questions? Let's do an example and I'll stop. Solve xn plus 1 equal nxn with x of there's a typo. Shoot. X of 1 equal to 2. Damn it. All right. So the solution xn is x0 product s equal to 1 to n minus 1, and this is an. You remember now an is n. Okay, an is n. So no, this is as. So that is, and x naught is 2. So this is 2 times the product s equal 1 to n minus 1 of s. Okay, so this is 2 times 1 times 2 times 3 times 4 times n minus 2 times n minus 1. Well, guess what that is? That is n factorial. So this is 2 times n factorial. Okay? So that is the solution. All right. So this is, well, I'm going to give you the day off tomorrow, and we'll pick it up from Monday. I think we have done good progress. I'm going to call my wife to stop the recording. Anybody have any questions?
Yeah, I have a question about the homework. So is it supposed to be a group submission or individual? Like, I understand that we have to form a group, but do you have to we have to submit or one person
No.
submit? Okay.
Each group will submit one homework, one copy. That's it.
Okay, all right.
So if you have a group of 3, you will only submit one homework, but all the names will be listed on it.
Got it.
Got it? Anything else? All right. Hi. Can you, yeah, stop recording and leave the meeting.